In my earlier video, I had seen what is the annihilating polynomial, minimal polynomial and characteristic polynomial. Also, I had discussed different type of example which had come in competitive exam. Today, I will discuss some more example about this topic which had come in different type of competitive exam. First example, which had come CSIR net December 2018 exam. The question is, consider a linear transformation T from Rn to R, which be the linear map which satisfies the condition T square equal to T minus identity. Then which of the following statement are true? Option 1, T is invertible. Option 2, T has real eigenvalue. Option 3, T minus identity is not invertible. And option 4, T cube equal to minus identity. Notice, this type of example I have discussed in my previous video. So, if you don't see my previous video, at first I will highly recommend you, please see my previous video. Then today's video would be so easy. Here the mapping T from Rn to R, Rn which satisfies the condition T square equal to T minus identity. That means the annihilating polynomial would be x square minus x plus 1 equal to 0. This is the annihilating polynomial. Now I will find the minimal polynomial, because in the question has indicate about the eigenvalue and about the is the operator is invertible or not. That means we have to find what is the eigenvalue of this linear operator. Here notice b square minus 4ac equal to 1 minus 4 times 1 times 1 which is equal to minus 3 which is less than 0. That means obviously for this annihilating polynomial always the root be complex root. Consider the root alpha beta which is complex. And since minimal polynomial always divide the annihilating polynomial, so the possibility of minimal polynomial would be case 1, x minus alpha, case 2, x minus beta, case 3, x minus alpha times x minus beta. Okay, and we all of us know root of minimal polynomial is the root of characteristic polynomial. Okay, since here the root is alpha, that means, and since alpha be complex number, so when alpha be one root, then their conjugate always will be exist. But if we consider the minimal polynomial be x minus alpha, then their conjugate cannot possible. That means we cannot consider this minimal polynomial. Similarly, if we consider x minus beta, then their conjugate cannot be possible. So we cannot consider this minimal polynomial. Case 3, if we consider x minus alpha times x minus beta, that means root and their conjugate always possible here. So we can consider this minimal polynomial. That means minimal polynomial of this annihilating polynomial or of this operator would be x minus alpha times x minus beta. And since root of this minimal polynomial is alpha and beta, where alpha beta both complex number, then option 2 is a wrong option, because option 2 has indicate t has a real eigenvalue. This is cannot possible. And option 1 indicate t is invertible. Is it possible? Actually, this type of example I have discussed in my previous video. From this root of this minimal polynomial, we can tell this is also root of this characteristic polynomial. This is true. But we cannot tell about the repetition, because here t with linear operator from Rn to Rn. But since alpha beta be the root of the characteristic polynomial which is non-zero, so obviously t would be invertible, because determinant of t always would be not equal to 0. That means option 1 also be right option. Then notice the third option. Third option has indicate t minus I is not invertible. For this, since t square equal to t minus identity, so apply determinant both sides. Determinant of t square would be determinant of t minus I, and obviously determinant of t square means determinant of t whole square equal to determinant of t minus I. And I have seen, since alpha beta be the root of this operator and both are non-zero, so determinant of t is non-zero. Therefore, since determinant t is invertible, and since determinant of t minus I is equal to determinant of t whole square, and since determinant of t not equal to 0, so obviously determinant of t minus I is not equal to 0. That means option 3 will be the wrong option, because here has indicate t minus I is not invertible, and option 4 indicate t cube equal to minus identity. This is also very interesting. Since our annihilating polynomial is t square equal to t minus identity, therefore here we have to find the t cube. That means multiply both sides by t, then t cube would be t square minus t. Now put the value of t square here, then this would be t minus identity. Here not identity, here t, because here t square minus t. Then this would be, just cancel this part, then this would be t cube equal to minus identity. Since here the operator is n cross Rn to Rn, that means here would be In. That means option 4 is a right option. Are you getting? This type of example are very important for any competitive exam. Okay, we will discuss another question which had come CSIR June 2018 exam. The question is, let A be an n cross n matrix with n greater than 1 satisfying a square minus 7a plus 12i equal to 0 operator, where I and 0 denote the identity matrix and 0 matrix, of order n respectively, then which of the following statement are true? Option 1, A is invertible. Option 2, t square minus 7t plus 12n equal to 0, where t equal to trace of a. Option 3, t square minus 7t plus 12 equal to 0, where t equal to determinant of a. Option 4, lambda square minus 7 lambda plus 12 equal to 0, where lambda is an eigenvalue of the matrix A. A square minus 7a plus 12i equal to 0 be the annihilating polynomial. A square minus 7a plus 12i equal to 0. That means the annihilating polynomial is x square minus 7x plus 12 equal to 0. That imply x minus 3 times x minus 4 equal to 0. So, from this expression we can tell minimal polynomial can be similar to before. Case 1, only x minus 3, or minimal polynomial can be case 2, x minus 4, or case 3, x minus 3 times x minus 4. Okay? And for this minimal polynomial, I will get 3 type of different matrix. For this, only eigenvalue 3, for this only eigenvalue 4, and for this eigenvalue 3 and 4. And since for 3 cases the eigenvalue are non-zero, so for 3 cases we can tell A is invertible. Are you getting? That means option 1 is a right option. And option 2 indicate t square minus 7t plus 12n equal to 0. Consider minimal polynomial be x minus 3. Then if we consider n equal to 2, then characteristic polynomial would be obviously x minus 3 whole square. Then trace of the matrix would be 3 plus 3 equal to 6, and determinant of the matrix is 3 times 3 equal to 9. Are you getting? And in the question has indicate t square minus 7t plus 12n equal to 0, where t equal to trace of a. If we consider this is the minimal polynomial, this will satisfy this relation where t equal to trace of a. That means t square minus 7t plus 12n equal to 0. Here t equal to trace of a means 36 minus 7 times 3 plus 12. Here n equal to 2. This value is equal to 36 minus 21 plus 24, which is equal to 39. Therefore, if we consider this is the minimal polynomial, then this equation cannot be satisfied, because we have to prove this is equal to 0, but I have got this is equal to 39. That means option 2 is a wrong option. And option 3 indicate d square minus 7d plus 12 equal to 0, where d equal to determinant of a. For d square minus 7d plus 12 equal to 0, where d equal to determinant of the matrix. And here I have got for this minimal polynomial, determinant of the matrix is 9. That means this is equal to 81. minus 7 times 9 plus 12. Which is equal to 30, and this equation also not equal to 0. So option 3 is also wrong option, and option 4 indicates lambda square minus 7 lambda plus 12 equal to 0, where lambda is an eigenvalue of this matrix. This option is obviously true option, because here lambda square minus 7 lambda plus 12 equal to 0 means from this minimal polynomial for case 1, case 2 and case 3, I have got either 3b eigenvalue or 4b eigenvalue or 3 and 4b eigenvalue. If we put lambda equal to 3, then you will get this equation would be 0. Also, if you put lambda equal to 4, also you will get this equation would be 0. Therefore, option 1 and option 4 be the right option. Are you getting? We will see another example which had come CSIR NET June 2018 exam. The question is, consider AB arbitrary matrix which is 3 cross 3 matrix, and here the field is real number, and matrix is such that this satisfy a to the power 8 equal to I 3 cross 3. Then option 1, minimal polynomial of A can be only of degree 2. Option 2, minimal polynomial of A can only be of degree 3. Option 3, either A equal to identity or A equal to minus identity. And option 4, there are uncountably many A satisfying the above. Here A belongs to M3 cross 3 matrix over R given, and here the annihilating polynomial A8 equal to I3 cross 3. Notice, annihilating polynomial of degree 8, but always minimal polynomial would be of degree 3. That means the annihilating polynomial x to the power 8 minus 1 equal to 0 operator. And since minimal polynomial always divide the annihilating polynomial, then possibility of minimal polynomial would be just x to the power 4 minus 1, x to the power 4 plus 1, and from this expression mx can be divided, since this is the irreducible polynomial, so minimal polynomial cannot be divided x to the power 4 plus 1, but minimal polynomial can be divided x to the power 4 minus 1. From this expression we can tell a to the power 4 equal to identity, and also minimal polynomial can be divided x square minus 1 times x square plus 1. Also minimal polynomial can be divided, since here the root is plus minus I. So minimal polynomial cannot divide x plus I, x minus I, but minimal polynomial can be divided x square minus 1, and this is equal to actually x minus 1, x plus 1. Also from this expression we can tell minimal polynomial can be either x minus 1 or x plus 1, and when one possibility of minimal polynomial would be x minus 1, or one possibility of minimal polynomial from this expression x plus 1. Other possibility also possible, but if minimal polynomial be x minus 1 or minimal polynomial be x plus 1, then option 1 and option 2 be wrong option, because here has indicated minimal polynomial of A can be only degree 2, But if we consider this possibility, here the minimal polynomial of degree 1. Also, from this possibility we can tell here has indicated minimal polynomial of A can be only, this is wrong option and this is wrong option because here has indicated only, for only this option, these two options are wrong option, and option 3 indicate either A equal to I3 or A equal to minus I3. Notice here A to the power 4 equal to I, obviously by this expression we can tell. If we consider minimal polynomial equal to x minus 1 times x plus 1, then A equal to I3 or A equal to minus I3 cannot possible. That means only option 4 is a right option. There are uncountably many A who is satisfying this above equation. Are you getting? Have you understood? What is the relation between annihilating polynomial, minimal polynomial and characteristic polynomial? Oh, okay. Oh, yes. Today I will stop here. In my next video, I will discuss what is the similar matrix and what is the relation of similar matrix with characteristic polynomial, annihilating polynomial and minimal polynomial. Okay? See you soon. Stay safe and stay positive always. And don't forget to do subscribe for more videos of my channel. Thank you so much.